Okay, so there was some confusion about how to calculate density for the project with the salsify data, and I wanted to just go over that and kind of show you sort of what was going on and the right way to do that. I realize we haven't covered density as a topic yet in class. We'll get to that in a week or so, but yeah, I just wanted to kind of highlight the issues here. So I have here the blank sheet. We'll kind of work through how to calculate these. So the first thing we need to do is get the average values of plants per quadrat here for this design. So we'll do average. We'll grab these guys, and that gives us a 0.6. I'm going to go ahead and drag that across to all these other cells. Okay, so our averages range from 0.3 to 1.4. Now, when we're calculating density, remember density is the number of plants per unit area. So we have to figure out what the area is, and this is where I think that my example here in the spreadsheet wasn't clear, and so as a result of that, I'm being kind of generous on the grading here because I think this was kind of my bad. So we need to know what the area of each quadrat was, and our quadrats were 20 by 50 centimeters, and so that's, again, we want this in meters, right? So that's 0.5 times 0.2 meters. So it's this kind of guy right here, this formula. So the way we're going to do this, and the example has you sort of multiply by 8, and where we get the 8 from is that it is 1 divided by 0.5 times 0.2, and so it's 1 divided by 0.125. That's a little bit of, for me at least, too much math in my head, right? So we're going to do this kind of the longhand way, and so we're going to say that our average density is 0.6 divided by, and then I'm just going to go ahead and do the math right here of 0.2 times 0.5. Now that's all in parentheses, right? Because that all has to be on the bottom of the division here. And then if I hit enter, that'll give me 6, right? I have this this value here of 6. I can drag that across here. Okay. Sorry, let me redo this. So to get my density, then I'm going to take this value of 0.6 and I'm going to divide it by my 0.2 times 0.5, right? Because each of my quadrats was 20 by 50 centimeters. That's in parentheses because that multiplication has to be on the bottom of this division, right? That's the denominator. And that's going to give me a value of 6. Now I can just drag this across to all the others, and here we go, 6, 14, 6, 3, and 14. I can add a little bit of precision there to that just for fun, right? Okay, so now let's take the standard deviation of this, right? It's a sample standard deviation, and here are my numbers. Okay, so that gives me a little bit more than 5 for my sample standard deviation. Now this is the standard error is also a place where there was a little bit of confusion, which is totally fine, right? It takes a little bit to kind of wrap your head around what the standard error is. But so here my standard error is going to be my sample standard deviation divided by the square root of my sample size, which in this case is 5. Okay, why is it 5 and not 10? Well, I have 5 transects, and at this point the transect is my sample unit, not the individual quadrats. Okay, I could do a standard deviation and a standard error for each transect individually, And in that case, the sample size would be 10. But here, because I'm going over each of the transects, my sample size is 5. Okay? And then my confidence interval here is going to be my 0.1. My standard deviation is right here, and my sample size is 5. And there we go. So 4.84 is the width of my confidence interval for this design. All right, so let's go down and let's do the same thing for this second design here of my 5 large quadrats. So, and then I'm going to get the average, and I'm going to get my density. Right now, in this case, right, so it's my average divided by, and in this case I have 50 centimeter plots. Okay, so it's 0.25 to divide by there, right? So that gives me 8. And in this case, there we go. Okay, 4.8 to 15.2. Where we ran into confusion with the example, right, is that it has you just multiply it by 1 over your frame size. And so in this case, our frame size is 0.25. So each frame is 1/4 of a square meter. And so here I could get the same answer by multiplying my number of plants per quadrat times 4 in this case, right, which would give me 8. Okay, but to me that's again too much math in my head. I'd rather just write it out sort of longhand here and use the actual frame sizes. Okay, so let's calculate the standard deviations here. The standard error, which is this guy, divided by square root of the sample size. Whoops, I made a problem here. Oh, I got too fancy here. Square root is not, it's not in, it's 5, right? There we go. And my confidence interval here, there's my standard deviation, and again my sample size is 5. So there we go. So a confidence interval width for the second design is 4.01, right? So it is smaller than my my original design, even though I have fewer plots here that I integrated over, or that I sampled over, right? The confidence interval itself is smaller because the plots themselves are larger, right? Okay, now let's extend this, and this also was sort of my bad for sort of poor formatting on the original assignment, but these numbers here are just the plants per quadrat, right? And in this case, the quadrat was the whole transect, a 1 meter sort of swath along the whole transect. So we actually need to calculate the densities of these. So it's going to be 49 divided by, and in this case, my transect area is 24 times 1, right? Which is just 24 square meters. Okay, so it gives me a value of 2 and a little bit, right? And so in this case, it's going to be 137 divided by 30, and 48 divided by 22. This would have been really easy if everybody used the same transects. 43 divided by 30, and 174 divided by 30. Okay, now, so these numbers are a lot more in line with the numbers that we were getting from the other designs. And so I can say, now do the standard deviation here of these numbers, and the standard error, right, and my confidence interval here for the same thing, standard deviation and sample size. Okay, so look at this confidence interval width, right? It's 1.8 roughly, right? So that's way smaller than the confidence interval width of either of these other two methods. Well, why was that? Well, it's because this transect, this plot that we used, which is the whole length of the transect and 1 meter wide, samples over a much larger area, right? So our variability of our results is smaller altogether, right? And so that's the general take home here is that these when you're doing density, the larger plot that you can that you can accomplish, the sort of better the result that you get, the more precise of a result that you get. Okay, so again, I just wanted to clarify that. We'll talk more about density in a couple of weeks, but this was an issue that was on the homework. So thanks.